Convection, pressure, and wind. Convection cycles we have seen in Earth's interior, in the mantle, and this is what drives plate tectonics. Well, we're also going to see it in our atmosphere, and this is part of what drives weather. So, for our atmosphere and convection cycles, it has to do with the temperature. In Earth's mantle, it was the temperature at Earth's interior. For here, it's our air temperature. When air is heated, it's going to expand. So when you have a volume of so many air molecules, so in this example 9 air molecules, and that volume expands, you've still got 9 air molecules, but they're a lot more spread out. So that creates a low density. Well, in the mantle we talked about floating. The low density material floats. That's essentially what is going to happen to the air as well. It's going to rise up. So in a sense it is floating upward. Because it has a density that is lower than the air around it. When that happens, that creates a low pressure. Remember, pressure is the weight of air pushing down. So here you've got rising air, so there's not much pushing down. So that's when the temperature is hot. What if the temperature is cool? Well, it's kind of the reverse. The air is going to shrink. So now we've got our volume of air molecules that gets smaller. So you get a higher density. And so that's going to sink downward. And so we can think of that as sinking or falling. But either way, if you think about pressure as the air pushing down, so if the air is falling, then there's more pushing down. And so that creates a high atmospheric pressure. How does that relate to wind? Wind, it turns out, is a result of a pressure difference. So our general rule of thumb is that wind is air moving sideways, so it's not the up and down motion of convection. This is a sideways motion, and it always goes from high pressure to low pressure. If you think about convection cycles that we saw in our mantle, something sinks down, goes sideways, goes back up, goes sideways. So here's our sinking air. Here's our wind. Here's our rising air. And if you were up at high altitudes, you would have wind up there as well. But this is the wind that we typically think of, because that's the wind that is here where we live, not up where airplanes are flying around. And so our wind is always going to be going from high to low pressure. If you think about, high pressure, we've got a lot of air trying to come down here, it's got to go someplace. Well, low pressure is kind of creating almost like a vacuum, so it travels over to that vacuum and then gets sucked up into the air. The bigger the pressure difference, the stronger the winds. And that's why when you have a strong weather system coming in, you get very strong winds, because that's an indication that there's a big difference between your current weather and the weather that's coming, and that's because of the big difference in pressure. That big difference creates those strong winds that we associate with stormy weather that's bringing in a big change. So all of this comes down to convection, what the air is doing, how that creates our pressure systems, and how the pressure then leads to our winds.